So the Ethereum virtual machine is the machine in which the state of the Ethereum blockchain is modified. Now here on the left side you can see some example EVM code, right? So you can see here these are like particular opcodes, like push 60 pushes the value 60, for example, on the stack. You have mstore, call value, you have jumps, right? As we have jumps in Ethereum, this is basically the EVM code if you dissect a particular smart contract or function, a transaction that calls a particular smart contract. Now, if you want to look if you want to get all the details of these particular opcodes here, you can go to the Ethereum yellow paper. It defines most of them. Now, the EVM features a stack that has a max depth of 1024. So this is the maximum number of elements that you can push on the stack. So if you write a smart contract, for instance, that pushes too many variables on the stack, you might hit that limit, and this can actually happen quite quickly. It has 32-byte words and dedicated crypto opcodes, for example, for SHA-3 or the Galois field 256 operators. What's quite important if you consider programming smart contracts is to understand how Ethereum handles memory. And there are two different sets of two types of memories that you can handle with. There's first the storage and there's the memory. The most important difference is that storage is permanent and memory is volatile. And because storage is permanent, it's also quite more expensive than memory. So memory is zero initialized and is arranged in 256 bits words. And storage, as I mentioned, is very expensive because it's permanent. Now you can perform some computations to understand how expensive, in particular, how expensive it would be to store, for example, 1 kilobyte of data in the storage or the memory. So we start basically at the yellow paper, right? And there you can find. So there's a fee of 20,000 gas to store a 256-bit word. So if the gas price is 10 gigaway, which is true, but I mean the recent gas prices were between 200 to 500 gigaway, right? So depends on the congestion of the Ethereum blockchain. 10 gigaway corresponds to 10 to the power of 10 way, which is 10 to the power of minus 8 ether. Now, 1 kilobyte of data would then correspond to 640k gas, which correspond to 0064 ether. And depending on the ether price, you can calculate then the specific US dollar value to store, for example, 1 kilobyte of data. So you can see it is quite an expensive endeavor to just store 1 kilobyte of data depending on the current gas price and the current Ethereum price. So the EVM provides an API for programmers to actually interact with the blockchain. I think the one of the most important understandings of this API is, for example, to know how much gas you still have remaining, how much memory you have used. You can understand the block timestamp. If you want to use, for example, in your smart contract, if you want to use the block timestamp for some kind of logic within your smart contract, then this is quite useful. But be aware that the timestamp can be manipulated by miners to some degree. You can get the block hash if you're interested in this. The miner. What's quite useful and which is actually used very very often is message.sender to understand who sent a particular transaction. You also want to know how much value was transmitted to this particular transaction and what the gas limit is. So how much gas can be sent. So as an output, you get the sent messages. You can get logs. You can also self-destruct. So you can for example, destroy a smart contract if you allow that particular function. You can free up space, where the EVM will grant you basically a credit for freeing up space. So that's a self-destruct functionality. I mean, the EVM provides several other APIs, which can be all looked up in the Ethereum yellow paper.